Alrighty, so this will be our final exam review. Let's see first. The exam will be uploaded to Canvas Thursday morning. And just like our previous exams, you download the test, work it out. You can either work it out on the exam itself or a separate sheet of paper, however you like to do it. And because, of course, our course did not have a set day and time, there's no particular set schedule for our exam. I don't know who has exams on Thursday, who has exams on Friday, and so on. So just to be as fair as I can be, I will allow this exam to be submitted by Friday at 11:59 p.m. So way more than enough time to take this test. I would suggest you don't wait till Friday to do it. You should, if you have the ability to, you should take it on Thursday. That way, if you have questions or anything or issues pop up, you can email me and there's sufficient time to talk back and forth on whatever needs to be talked about. And also, you should submit it as early as possible in case there are issues technically with the computer or the internet or anything like that where it doesn't accept your submission. We can remedy it because I cannot accept late submissions for this final exam. Once 11:59 on Friday has come and gone, I will not accept any late submissions. So be very careful with that. Now, with the format of the test, of course, the good news is you've already taken tests from me before, obviously. So you know what my tests look like. I make the final exam. It's not departmental. So you have a very clear picture of what this final exam will look like. Same types of questions that were on the other tests, all calculations. You have a formula sheet you can use. So you know what to expect. Nothing's going to change. As for the topics, this is cumulative. So that means all the topics we've gone over in this class will appear on this final exam. To be more specific, of course, let's try to go through them, figure out what we've done this whole semester. The first big topic was position versus time graphs. And velocity versus time graphs. So either you're given a story or you're given a graph of the position versus time of some object moving around, and you're asked to create the velocity versus time graph for that object, or vice versa. I give you the velocity versus time graph, and you have to create the position versus time graph. We had multiple examples of this, and it was on the first test as well, so you know how it looks. Being able to look at a graph, interpret the graph, what does it mean? You know, if you have position versus time, the slope of the graph tells you the velocity. The steeper the slope, the faster the velocity. If it's sloping up and to the right, it's moving forward or in a positive direction. If it's sloping down and to the right, it's moving in the negative direction. If it's a horizontal line, it's not moving at all. It's stationary, and so forth. From there, we had kinematics, one-dimensional kinematics. And so you had questions that dealt with, x equals v naught t plus 1/2 at squared. Vs squared is v naught squared plus 2ax, and things like this. Acceleration is change in velocity over time. So you had, a car is moving along, going 30 miles per hour, or 30 meters per second, let's say, and it slams on the brakes, coming to stop in 2 seconds. if the so the car was initially moving at 30 meters per second, what must have been the acceleration? So what's the A? Which equation will you use? Plug in the numbers. Or an airplane is traveling at a certain speed, and it hits a tailwind, and for 5 seconds, how much faster is it going? How far does it travel? Those types of questions. Objects moving around, the relationship between distance and time and velocity and acceleration. After that, we had Newton's laws, which dealt with forces. F equals ma. We had multiple forces acting on a block. What's the acceleration of the block? We had pulleys. We had elevators. How heavy do you feel in an elevator, for instance? We had the third law, which were the questions like, you have multiple blocks connected by ropes, and you pull on the system with a certain force, and you want to know what's the tension in each rope. All of these are example of Newton's law type questions, force type questions. After Newton's laws, we had work and energy. So work, remember, is force times distance, where it's a dot product, which means it's the amount of force in the direction of motion. So if the object moves in the x direction, you want to know what are all the x forces. If the object moves vertically, then you want all the vertical forces, and so on. And then, knowing the work, we can then use the work energy theorem, which said work is equal to change in kinetic energy. Where kinetic energy, of course, is 1/2 mv squared. And finally, conservation of energy. So conservation of energy were the big ones, very important type questions, but also kind of the more easy questions. And here you have, a hill, and a block is at the top of the hill. If the hill is 10 meters tall, you want to know how fast is the block moving at the bottom of the hill. And for this, we need a kinetic initial plus potential initial is kinetic final plus potential final. Knowing kinetic energy is 1/2 mv squared. If you're moving, if you have a velocity, you have kinetic energy. For potential, there were two. There was mgh, which is gravitational. If you're some distance above the ground, then there's mgh. The other is spring potential energy, 1/2 kx squared. If you're messing with a spring, compressing it or stretching it, then there's some potential energy due to a spring. And so the way you would go about handling these questions was you would look at the initial state, and you'd ask, is the object moving? If it is, 1/2 mv squared. If it isn't, 0. Then, is it some distance above the ground? If so, mgh. If not, 0. And then lastly, am I messing with a spring in the initial position? If so, 1/2 kx squared. And if not, that's 0. Once that's done, you have all the information for the initial side. So then you look at the final side and you ask the same 3 questions. Am I moving? Am I some distance above the ground? And am I messing with a spring? That'll give you the right side of the equation. Once all that's written out, then you'll have everything you need with only one unknown sitting there, and you just solve for the unknown. So how's conservation of energy style of problem? From there, we kind of switched it up a little bit, and we went into circuits. And with circuits, of course, we had V equals IR, that's Ohm's law. And we learned how to add resistors together. If they're in series, you just add the resistors. And if they're in parallel, then you add the reciprocals. So, given some circuit, can you find the total current running through the circuit? Well, in order to do so, you'd first, of course, try to combine all the resistors together in series and in parallel, a combination, until you get down to one single leftover resistor. Once you know that total resistance, then you use Ohm's law, V equals IR, to solve for I. The last topic was optics. With optics, we dealt with refraction, and critical angle. And for both, we could use Snell's law, which says N1 sine theta 1 is N2 sine theta 2. So, light coming in at an angle of 30 degrees hits the surface of a pond. What's the angle of refraction of the light going through the pond? Well, you use Snell's law. The index of refraction for all the materials will be given on the test. You don't have to memorize them. But index of refraction for air is 1, for water is 1.33. So you say N1, that's water, that's air, so 1 times sine theta 1, the angle in the air was 30 degrees, equals, we're now in the water, N2, 1.33, times sine of theta r, which is our angle of refraction. And we solve for theta r. When discussing critical angle, this is the phenomenon when we're going from one medium, more dense medium, so let's say from water, and we're sending light into the air. If we send it at a very specific angle called the critical angle, then instead of the light leaving the water and going out into the air, that light skims the surface. Which means, basically, that theta 2 is 90 degrees. And so you would use Snell's law, solve for theta 1, which will be your critical angle, such that theta 2 is 90. And that's how we do critical angle. It's still Snell's law, it's just a special case of Snell's law. The special case being you're in theta 1 and you're trying to get to theta 2, where theta 2 is 90 degrees. And then you solve for theta 1 and you get your angle. And remember, you can only have a critical angle if you're going from a more dense to a less dense medium. So I can't go from air to glass. That will not give me a critical angle. But I can go from glass to air, or from glass to water. That can work. All right, so those are the topics. How would I study, given that there's a limited amount of time? First thing I would do is take the old tests that you've already taken, get a blank sheet of paper, and redo the tests. Work those tests out again. Make sure you can do them. If there are any topics you are having trouble with, put a star next to them, mark it down. Any topics you're killing, then fine, breeze through them, and move on. Once I'm done those, these particular topics, circuits and optics, we have not had a test on yet. So I would work the practice problems that are associated with those topics. Make sure you can do those practice problems. No matter which one I choose, you'll be able to work it out. Once that's done, if you happen to have leftover time and you want some more practice, then go to the old practice problems and work those for the other topics. Now, you should, having gone through the old tests, if there were any topics you had to mark as being trouble, those are the topics you should concentrate on when working practice problems. Look at the solutions, see how I work them out, and try to see why you're having trouble, where you're going wrong, things like this. Definitely start studying as soon as possible. That way, over the course of this week, before Thursday, You can email me if you're having trouble with anything, if you want me to look over a question that you're working on or whatever. Then there's time for us to communicate back and forth on it. So, but definitely feel free, email me if you say, look, I'm working this problem. I don't seem to get the same answer as you. Can you look at what I'm doing? Or I'm stuck here. Can you give me a hint on what I should do next? And I'll be happy to look over it. And if I have to write something out myself, I'll write it out and send the picture back to you. But take advantage of it, because once Thursday comes and you have to work on a test, well, now you're working a test. So that's it. That's the final exam. The only other thing I'll mention, of course, remember, Thursday morning will be posted, and it's due no later than 11:59 p.m. on Friday. When you submit it, you definitely need to submit the work along with your answers. I cannot just accept answers because, number one, if the answer is wrong, then you get 0 partial credit. It's just wrong. Whereas someone else who was showing the work, maybe they did a simple calculation mistake or something like that. Well, I can see they're doing everything correctly. They just have a calculation mistake. So I can give partial credit. If you don't show work, there's no partial credit possible. Furthermore, if you don't show work, then how do I know you didn't just call someone up and ask for the answers? How do I know you work these problems? I can't know that. So then why should I give you credit for solving the problems? So on this test, you need to submit the work along with your solutions. Also, I've seen, not just this class, but other classes, people, when they're working a test question that happens to be similar to a homework question, all of a sudden, the solution is the solution to the homework question. And so they're basically copying the homework work and submitting it as the test work. Well, that's obviously wrong. I only want to see the answers to the test questions. So be sure, if you are using your homework or your notes to help guide you into how to solve these problems, be sure that when you're submitting the answers to this exam, that you're solving the problem in the exam. You're not solving the problem in the homework. I can't give credit if you're not answering my questions. So just be careful about that, because I understand if you're rushing through something and you get the questions confused, you forget which one you were working on. But with this, there's no deadline. It's not a 2-hour test. And you have 2 days to work on this, so there's no rush. Take your time, work through the problems correctly, and just make sure that whatever you submit are the solutions to your exam, not someone else's exam and not the homework. But anyway, with that, I hope this helps you figure out how to study. Like I said, you should be comfortable with the format of the test by now. You know what to expect. Work a bunch of problems. Make sure you can answer the exam problems, because I thought those were important enough to ask once. Likely that's the kind of question I would ask again. Not guaranteed, but if I thought it was important, it's important. And then, of course, practice the practice problems, especially for the topics you have not been tested on yet. The more practice you can get ahead of time, the more comfortable you're going to be on the test. With that, I wish you luck with the studies.